Hello class, let's take a look at this question here. This is going to be a difference of means hypothesis test problem. And on this particular problem here, researchers are studying magnets as far as their ability to treat back pain. The results are shown in the table below. We want to find out if the results are effective. Assume the two samples are independent and normally distributed. Do not assume the population standard deviations are equal. Okay, so we don't know if the population standard deviations are equal or not. Complete parts A and B below. Use alpha 0.05. So the first thing we need to do is set up the hypothesis test. And let me see here if I can find the statement here. Test the claim that the treatment that those treated with magnets have a greater mean reduction in pain than those with the sham treatment. Okay? So greater means greater than, obviously, which means one-tailed test. Remember that the alternative hypothesis will never include equality. So answer D cannot be true because answer D includes an equality statement in the alternative. B, C, and A are valid statements with regard to the alternative. C is invalid for the null statement. The null statement must include equality. So C is eliminated. So now I'm down between A and B. It has to be A because B is a two-tailed test. B is not equal to or different. That was not the question. The question is greater than. So therefore, A is the statement. This is a one-tailed test. Let's do the test statistic and the p-value using StatCrunch. So go to stat, tstat, two sample with summary. The values are right here. The mean is 0.48. Standard deviation is 0.64. Sample size is 16. Second group, 0.44. Standard deviation, 1.19. And 1.19, excuse me. And the sample size is again 16. Now, pay attention to this statement right here. Do not assume that the standard deviations are equal. So that means that we will not be pooling the variances. Change this to greater than because it's a one-tailed test. Move this up a little bit, hit compute. The test stat to 2 decimal places is 0.12. The p-value to 3 decimal places is 0.453. Now, the p-value is bigger than alpha, 0.05, so we will fail to reject the null. There is not sufficient evidence to support the claim. Okay, since the sample mean for those treated with magnets is greater than the sample mean for those given the sham treatment, it is valid to argue that magnets might appear to be effective if the sample sizes are larger. Okay? So in this situation here, okay, it does not appear that there is a difference. However, it does appear that the treatment is on average better than the sham, but not statistically better than the sham. Let's find the confidence interval. Stat, tstat, two sample with summary. And once again, I need to re-enter this information. 0.48, 0.64, 16, 0.44, 1.19. I did it again. 16, and again, turn off pooled variances. I want a confidence interval, and the confidence, okay, Let's pay attention to this. This is very, very important. I want you to pay attention to this very, very carefully. Okay? Where did my page go? There it is. Let's talk about this. We have a situation here. My hypothesis test was a one-tailed test. Confidence intervals, by definition, are two-tailed tests. In order to come up with the equivalent or the suitable, as they use the word suitable here, confidence interval, I have to take 0.05 in each tail for a total of 0.1. That means the confidence will be 0.9. Okay? This is the adjustment that I have alluded to in other videos. Hit compute. The lower limit is negative 0.539. The upper limit is 619. And that is your answer. Okay? Thank you.